Good afternoon, everyone. I hope that you've had a great week and everybody's doing good today. We're looking today at a continuation of section 31.15 or lesson 31.15 if you like. I'm just calling this part B and we're looking at more area examples today. There's only 2 examples we're looking at. It's a fairly short lesson. And then we're going to continue with part C next week. This is on page 10 of your current lesson handout. The only difference here between the examples that we're going to do today and the examples we did last time is last time you were pretty much told that the area was enclosed from x equals one number to x equals another number. And here you're not going to be told that. This question just says, what is the area between y equals 25 minus x squared and the x-axis? So the first thing is you need to be able to come up with a visual of what the graph looks like. Y equals 25 minus x squared. And by the way, this is why, traditionally speaking, in a calculus course, you have a whole unit dealing with graphing functions. There is no reason why you should require a graphing calculator to know what y equals 25 minus x squared looks like. In fact, in this particular case, it's pretty easy to sketch it using your knowledge from Math 20. You know that y equals x squared is a parabola whose vertex is at the origin, and that parabola opens up. You also know that if you take y equals x squared and multiply it by -1 to get y equals negative x squared, it's a parabola that opens down. And you also know that if you take that parabola whose vertex is at the origin and it's opening down and you add 25 to it, it shifts up 25. So everybody should know that what this parabola looks like is that. So what is this question asking you to find? It's asking you to find the area between the function and the x-axis. There is something implied here, and the implication is that you want to determine this area. Okay, so how are we going to do that? Well, we know, and I'm going to stick with my integral notation here when I do area problems, that it will be the integral from a to b of f of x dx because the function lies entirely above the x-axis. And this would be where a is, and this would be where b is. So we need to determine the coordinates of the x-intercepts. Well, that's pretty easy to do. We're going to take 25 minus x squared, set it equal to 0. I can solve this by factoring. It's 5 plus x, 5 minus x equals 0. Which means that one of the x-intercepts is -5 and the other x-intercept is +5. That means that my general statement becomes the integral from -5 to 5 of 25 minus x squared dx. Now I'm going to solve this problem with you, and then I'm going to solve it in a different way that would make your life a little bit easier. But the starting point is to say it's the integral from -5 to 5 of 25 minus x squared. What does that mean? It means we need to take 25 minus x squared and anti-differentiate it to get 25x minus x cubed over 3. And then we need to evaluate that expression, which is the general antiderivative from -5 to +5. And what that involves is putting +5 in for x, and then whatever that gives you, subtracting the result that you get when you put -5 in for x. Again, it's very easy to make a mistake here, so be very careful. My brain is feeling a little tired right now, so I'm going to use my calculator. 25 times 5 is 125. Then I have to subtract 5 cubed, which is 125 over 3. We get 250 thirds. For the second part, I get negative 125 minus negative 125 over 3. I think some of you see what's going to happen here. You get the exact same number, except it's negative. So we end up with 250 thirds minus negative 250 thirds, which means you get 250 thirds plus 250 thirds, which is 500 thirds of a square unit. And we can certainly check that on our calculator. There's nothing wrong with doing this. Our function is 25 minus x squared. I'll choose to go zoom 6. Go to my calculate menu and choose number 7, which is the integral of the function from negative 5 to 5. By the way, this illustrates an important point that you don't need to see the top of the graph. You only need to see the lower and upper boundaries. You get 166.6 repeating, and if you take 500 divided by 3, which was our answer, you get 166.6 repeating. Now, is there an easier way that you could have done this question algebraically? Well, certainly. Your knowledge of this graph says that it's a symmetrical graph with respect to the y-axis. And what that means, everybody, is that this side of the graph is exactly equal in area to this side of the graph. And if that's the case, then rather than finding the integral from negative 5 to 5 of the function, what I would have done, I would have found the integral of 25 minus x squared from 0 to 5. That way I don't have to deal with any negative 5 in my calculation, and I would double it. Let's see what happens there. I have 2 times the integral from 0 to 5 of 25 minus x squared dx, which means I have 2 multiplied by the antiderivative, which is 25x minus x cubed over 3 from 0 to 5. So I get 2 multiplied by the antiderivative at 5, which would be 25 times 5, minus 5 cubed over 3, minus the antiderivative at 0, which will be 25 times 0, minus 0 cubed over 3. The beautiful thing here is the second part of our calculation, this, is 0. So you're left with 2 multiplied by, well, 25 times 5 minus 5 cubed over 3, we've already seen as 250 over 3. Then we have our plus 0, but it doesn't really matter. You end up with the same answer. You end up with 500 thirds. So that's example 1. So the next example, which is example 6, says what is the area below this function and above the x-axis? When you take a look at this quadratic function and you analyze the leading coefficient, which would be negative 1, you discover that this is a parabola that opens down. And that means that the graph of the function will look like this. I don't know where the y-axis is. It doesn't matter. The area we're trying to find is this area, which means the missing pieces of information are that you don't know A and you don't know B. How are we going to find A and B? Well, what we're going to do is find the x-intercepts by solving this equation. I'm going to factor a negative 1 out. I know that we could multiply both sides by -1. I don't like to do that. I like to keep the negative as part of the function. And I get x squared minus 2x minus 63, which means 0 equals -1 times, what am I doing here? I guess I'm looking for two numbers that multiply to give -63 and add to give -2. That would be 9 and 7. Well, -9 and 7. Which means x is equal to -7 and x is equal to 9, which tells us a is -7 and b is 9, and now we can answer the question. It will be the integral from -7 to 9 of 63 plus 2x minus x squared dx. I don't think you want to break this into pieces. You could figure out what the x-coordinate is in the middle and find one of these areas and then double it, but you're still going to probably have to do just as much work. I think the x-coordinate in the middle will be 1, because to go from 1 to 9 is 8, and to go from -7 to 1 is 8. So I suppose you could do the integral from 1 to 9 and double it, thereby avoiding any negative values of x. I'm not going to do that. Okay, we are going to have to then take 63x plus x squared minus x cubed over 3, which is the antiderivative of the function, and evaluate it from -7 to 9. So we have to put 9 in first and then subtract the result of putting -7 in. So we have to put in 9 first and then subtract the result of putting -7 in. We're going to have 63 multiplied by 9 plus 9 squared minus 9 cubed over 3. Now, of course, we subtract the same thing at -7, so we will have 63 multiplied by -7 plus -7 squared minus -7 cubed over 3. Same thing I've always tried to teach you. When you do substitution, use a set of brackets around everything you substitute. Again, I really don't feel like trying to crunch any of these numbers in my head, so 63 times 9 plus 9 squared minus 9 cubed divided by 3. Now, I'm not putting brackets around the 9s in my calculator because 9 is a positive number, so it's not going to matter. I'm going to have to be careful with the -7 though. I get 405. Let's do the same thing now with the -7. 63 times -7 plus -7 squared minus -7 cubed over 3. This is what I was talking about with the brackets. 63 times -7 plus -7 squared minus -7 cubed over 3 gives me this number, which is -833 thirds. So we get 405 minus -833 thirds, which is kind of weird, but let's just play it out and see what happens. 405 minus my answer gives me 682.6 repeating, and in fractional form that is 2048 thirds. So 2048 thirds square units. Let's go to our calculator and hopefully confirm that that's the correct answer. We had y equals 63 plus 2x minus x squared. and we were going from -7 to 9. So if I go zoom 6, I should be able to see -7 to 9. This, by the way, is a nice confirmation right out of the gate that it has an x-intercept at -7 and 9. I calculate. Lower limit is -7, upper limit is 9. And we get 682.6 repeating, which was, in fact, what we got for an answer. So the answer is correct. That's it for today. The questions that I've got on your assignment are simply questions very, very closely related to the two examples we looked at today. Your goal is to use your knowledge of graphs of functions to determine the upper and lower boundaries of the area by looking at the x-intercepts of the functions. So I hope that made sense, and I hope you have success with this stuff and have a fantastic weekend. We will talk to you soon.